Hello students, let us try to understand the rubber. Okay, so already we have already covered the polymers students in the classification of polymers, types of polymerizations, examples of different type of polymer like addition polymers, you know condensation polymers. All we have discussed. Now next one topic is that is for the rubbers. Rubber is two types of rubber are there, student. First one is natural rubber and second one is synthetic rubber, right student? So let us have a look over the natural rubber student. So when you talk about the natural rubber student, that is rubber is natural polymer and possess elastic properties. It is also termed as elastomers and has a variety of uses. It is manufactured from the rubber latex, where you are preparing student from the rubber latex, which is a colloidal dispersion of rubber in water. This latex is obtained from the bark of the rubber tree and is found in India, okay, Sri Lanka, Indonesia, Malaysia, and South America also. Okay, natural rubber may be the considered as the linear polymer of the isoprene. Isoprene is what student? 2-methyl 1,3-butadiene diene. So meth, 8, pro, but, and on the second position methyl is there, and they are saying one position and third position there is double bond is there, butadiene. So here CH2 student, here is that is CH, and here is CH2. So this is what student 1,3 but, this is 2 methyl, right student? 2 methyl 1,3 butadiene. Okay student, this is what 1,3 butadiene. You can write in the bracket, it is the natural rubber, right student? This is the natural rubber and is also called cis 1,4 polyisoprene. So it is also called cis 1,4 polyisoprene. Now let us have a look over the another. This is the now buta 1,3 no 2-methyl 1,3 butadiene is having, if you, they are combined, it is forming this type of structure they will form. Okay, next one is, if you are talking about, this is isoprene, what they are saying, the cis polyisoprene molecule consists of various chains held together by weak van der Waal interaction and has a colloidal structure. Thus it can be stretched like a spring and exhibit elastic properties. So because of this van der Waal interaction, okay, and has a colloidal structure, thus it can be stretched like a spring and exhibit elastic properties. Okay, next point you see student, what is the vulcanization of rubber, that we have to understand student. This is the quite important topic for the CBSE board student, board exam. They are saying vulcanization of rubber, that we have to understand. So natural rubber becomes soft at high temperature like the 335 Kelvin and brittle at low temperature, like below 283 Kelvin. The and so high water absorption capacity, you know and so high water absorption capacity at low temperature. It is soluble in non-polar solvent and is non-resistant to attack by oxidizing agent, means no oxidizing agent can degrade it. Okay, to improve upon these physical properties, a process of vulcanization is carried out. To improve the physical properties, we have to do the process of vulcanization. This process consists of heating mixture of the raw rubber with a sulfur and appropriate additive at temperature range between 373 to 415 Kelvin. So you are heating this natural rubber with the sulfur. This process changes the physical properties, which is known as vulcanization. Now, if you talk about on vulcanization, sulfur form, what sulfur will form student? Sulfur form cross link at the reactive site of double bond and thus the rubber gets stiffened. It is manufacture of tires rubber. 5% of sulfur is used as a cross linking agent. Okay, it is manufacture of tires rubber, i- in manufacture of tire rubber, 5% sulfur is used as a cross link agent. The probable structure of vulcanized rubber molecule are depicted as below. So this is, here is the cross linked sulfur molecule here between the isoprene chain. So this is what the vulcanization of rubbers. Next one is, student, synthetic rubber, right? Let us have a look over the synthetic rubber, student. Synthetic rubber is in any vulcanizable rubber like polymers which is capable of getting stretched to twice its length. So synthetic rubber, what its capacity, student, that it can stretched twice of the length. Whatever, if 1 meter length is there, it can stretch out the 2 meter. However, it return to its original shape and size as soon as the external stretching force is released. So if you are removing the stretching force, it will return to, you know original side. Thus, synthetic rubber are either homopolymers or 1,3-butadiene derivatives, or copolymers of 1,3-butadienes or its derivative with the another unsaturated monomers. So this is all about the synthetic polymers. Synthetic polymers means the polymers which can stretched twice to its length. Preparation of synthetic rubber. So first one rubber is the neoprene. Okay, neoprene is synthetic rubber, student. So neoprene or polychloroprene is formed by the free radical polymerization of chloropene. So this is the chloropene, or you can say 2-chloro 1,3-butadiene. It is polymerized to give the neoprene. It has super resistance to vegetables and mineral oil. It is used for manufacturing conveyor belt, okay, conveyor belt, gaskets and hoses. So these are the applications. How it is forming, student, that is neoprene. You can have the look over it. That is CH2 double bond C. Here is Cl, here is CH double bond CH2, right? This is n time, and this is what is going on, that is polymerization. Okay, polymerization, right? So if it is going polymerization, it will be going, the one bond is here, one bond is here, and out of these two, one electron will be moving here and one electron is moving here. So that will result in the double bond. So here is the CH2, it will be the single bond. Here is C, this will be the Cl, and here is the CH. Okay, student, this is CH2 and single bond. Here is N time. This is what is neoprene. This is what is, student, this is neoprene. So this is what. Next one is the synthetic rubber is the buna N. This is also buna N. This is the form by, you have already studied about the buna S in the section 513. Buna N is obtained by the polymerization of 1,3-butadiene. Okay, 1,3-butadiene, you know very well, that is meth, eth, pro, but. Here is the diene is there, 1,3, and here is single bond. So this is CH2 and here is CH2. This is CH and this is also CH. So this is what, student, this is 1,3-butadiene. Now, and acrylonitrile in the presence of peroxidized catalyst. Okay, so what we are saying, that is we are taking 1,3-butadiene and acrylonitrile. So acrylonitrile means what, student? CH2 double bond C H, and here is Cn. So how it is forming, student? One electron here, one electron here. Okay, one is here. This will be the one electron here, one electron here. This is the, and it is like that. So if you see how is, where is the double bond? So this is single bond here will form, that is CH2. This is CH, and here is double bond, that is CH, single bond CH2. This is single bond. Here is CH2 and here is CH, single bond. Here is, that is CN. This is the N type. This is, student, this is what is buna N. Okay, what is the use of buna N, student? It is resistant to the action of petrol, lubricating oil and organic solvent. It is used in making oil seal, tank, lining, etc. So this is all about the rubber, student, whether it is the natural rubber or the synthetic rubber. I told you natural rubber is prepared from the latex, okay, from the rubber tree, and that is the polymer of the 2-methyl 1,3-butadiene. And when you are talking about the synthetic rubber, student, it is the when the you are adding some other reagent. Okay, so the any rubber which can stretch up to the twice of its length, that is what is known as synthetic rubber. Vulcanization of rubber is also there, student. Vulcanization means the rubber, vulcanization of rubber means what, student? If you talk about the vulcanization, if you are adding the sulfur to it and heating, it is give the vulcanization of rubber. Thank you so much for watching, friends.